pull pretty much everything together to look at some hazards today. We're going to focus on icing. We're going to look at flight categories. We're going to look at some thunderstorm stuff. And we're going to look at stratospheric ozone. So kind of pulling a lot of the hazards that you deal with as a pilot together. So we'll start out here in the West Coast because that's where everything's kind of interesting. As you can see here, there's a pretty strong low up over Idaho, cold front coming down through the Rockies, warm front out ahead of the low, a little bit of a stationary front here as well, across southern Montana. So if you were to look at this map, where would you think there might be some hazards? I guess is where you're looking for right now. Well, I think if I was flying, I would be a little bit worried about some low ceilings up here, north of the warm front, that there might be some overriding air coming up from the south, pushing ceilings down. That would be one area I would look at. Oh yeah, I might have to think about some icing up here too. After all, there could be some warm layer aloft that hasn't got down to the ground yet. So if I was flying through that layer, I might actually encounter water that's above freezing and then go to another layer that would be well below freezing, especially if I was landing. Wind shear is another obvious one that would be thought of here. On this side, more cold, lots of flow down along the coast here in California and Oregon. Oh yeah, there's lots of moisture beginning to come up in this part in Arizona and all too. So maybe there's some things I got to think about out there as well, out ahead of it. Maybe even some convection might be popping into here. So this is just looking at a surface map. And all it's doing is saying, okay, I may have some issues out here. So if I am a pilot, I need to be thinking about what issues I might be having. And if I'm going to have them, where might be the safer way to go to get away from those issues? And knowing where a front is, knowing how it's changing, all of that can give you a perspective on where to move to. So let's take a look at some soundings right now. These were soundings we're taking this morning. And this was in Reno, Nevada. So if I was looking for the tropopause, I would argue it's right about 6 kilometers up. And that's where the temperatures begin to warm with height. So if that's the case, what that means is there's a very deep trough out in the West Coast. So if you were flying, and all you would have to be is basically like 20,000 feet or so, and you would be in the stratosphere out here. So if you're in the stratosphere at 20,000 feet, you better be thinking that you're going to have more ozone to deal with and all. So the higher up in the stratosphere, the more ozone layer you might get into. So because of the way the trough is situated out there, that's a very cold trough, a very deep trough. You're actually getting into the stratosphere and have ozone to deal with at a much lower elevation than you might have thought about. So it's just one aspect of this storm. This storm has a nice surface reflection up here, but there's a very deep trough out here to the west of it. And what you can actually see here on 300 millibars, you can actually see it, and it's actually cut off over that part. And that is where the tropopause dipped down, and we wound up with the stratospheric air. Now, what about icing? Well, let's look up north of that cold front. And what do you see? Well, you see, here's your warm layer, just like we were looking at. So if you were flying across Great Falls, Montana, you would be hitting a warm layer of between 1 and 2 kilometers, where the temperature is well above freezing. However, if you're in the clouds, and if you went down, coming towards landing, you're going to hit a layer down here towards the surface, where the temperature is actually down around 29, 28 degrees in this area right in here. So what's going to happen with that water that might have accumulated somewhere? It's going to begin to freeze on your aircraft. So icing is going to become an issue. You might have it the other direction, but you'll probably be colder and more just pure ice crystals instead of water to deal with when you go further up. So that wouldn't be as much of a problem. So you get away from the icing up here. But again, all things to think about and understand when you're looking at flying out west today. Let's take a look along the extreme west coast. Look at how much moisture is out here. Pretty deep moisture, and it's coming in off the ocean. So if I'm looking at satellite here, what I'm seeing is a tremendous amount of moisture. Air is pretty cold. Look at all the cumulus clouds that are forming out here. So the air is actually relatively cold low to the ground. Remember, instability from those cumulus, even though the ocean is a relatively cold ocean, it's not as cold as that air. So what you're winding up with, a deep trough, the actual cold front's way down here, now almost into the Baja, but you can actually see all this Q field. So if you're flying across the Pacific at low elevations, you might have some issues. You can actually see moisture wrapping up from the Pacific and in here. Some lower clouds in the southern part of California due to this. So let's take a look at some other aspects of this. There is something called daytime cloud phase. What it literally tries to look at where icing might be occurring in the clouds and where you might find some other. So it's finding, what it's finding is that there's some cold clouds, especially over here in the mountains and all, which are all below freezing. But there actually is an area right in here and maybe somewhere towards Arizona and all, where there are some clouds that are kind of mixed phase. So if you were flying through there, you would have some ice and you'd have some water to deal with. So again, that could be an issue. If we looked at the jet stream out here too, there's some really strong winds out here to the west, 100 knots, 110 knots here, and it's curving right in here. Lots of turbulence probably today out here as well. There's another jet way up to the north. That's why there's nothing coming down with this front. This front isn't rapidly moving to the east. It's kind of blocked. So all of that brings us back to the aviation weather page. And you can see here they're actually calling for some icing where we were looking at it down here, some convection out here, but some other things you can look at here. Because we were looking at icing here, let's take a look at where some icing might be happening. This is just an icing forecast, and you can see there's a lot of potential for icing, particularly down across the mountains here in the Rockies in Arizona, New Mexico, Colorado, Utah, and there's some more back in here, and some along the immediate coast here. So, and with this, you could actually zoom in, change elevations or whatever. But what I wanted to really focus on right here a minute would also be just to take a peek back at it. And you can actually see the freezing level here. And here's your freezing level. Pretty deep, almost down to the ground right here. But lots of warm air to the east. But you can really see how the freezing level, even along the California coast, is dipped down pretty low. So that's where your cold air is coming in behind the backside of this front. Well, another thing with icing you got to deal with as well. So one of the things, other areas they have is something called prog charts. And I just wanted to take a quick peek and see if we can find where some low-level ceilings, IFR, MVFR ceilings might be. And you can see here over the Rocky Mountains, where we saw those trough in the low pressure to the north. And look at this big area IFR right to the north of that cold front, just like we talked about. So again, just looking at surface features, you were able to anticipate where you might find into some of this. So, and you can actually look through, see how it's going to change with time, move forward with it as well. So this is really what I wanted to focus on this week. All these different areas you're going to have to deal with. You've got electricity, lightning, they're talking about in here. And while lightning can be an issue, definitely if you're flying through, if you get hit by lightning, it can actually fry your panel or at least temporarily shut it down where you have to come back and restart all your electronics within the aircraft. Volcanoes, dust from them, tremendously hazardous for any aircraft. Think about it. The propellers inside the jet engines or any other type of aircraft, it hits that micro dust and goes through it. That's going to cause a lot of problems. So that's why we try to avoid flying into volcanoes or through the dust from an eruption. So if you have any questions about this, just let me know.